All right, welcome folks. So let's have a look at a starter problem to begin here, right? So we got two regular pentagons and we want to show that, the question asks, must the pentagons be congruent? Okay, that seems pretty fair. So we know that these are all regular polygons. So the regular pentagons here, right, that helps us out a lot. We know that means all the sides are congruent, all the angles are congruent here. So all these sides are congruent, that's going to be important here. And all these sides are congruent here, okay. Note that these are pentagons, so that means each interior angle is going to be 180 times 5 minus 2 divided by 5, right? Because we know that's the case for a regular n-gon. So that's 180 times 3 over 5. 180 and 5 have a common factor of 36. So that, 180 over 5 is 36 here, so we end up with 108. So that means each of these angles here is 108. So we have a bunch of 180-degree angles here and a bunch of 180-degree angles here. Useful. Okay, well, we know in this situation, it looks like I've got some expressions here. I got 5x minus 2 and 6x minus 5. And because these are regular pentagons, these should all be the same. So therefore, I can write that 6x minus 5 equals 5x minus 2 here, and I can solve here, right? I can solve this sort of situation. Let's subtract 5x from both sides here and add 5 to both sides. This works out, and we end up with x equals 3 here. Okay. So we get x equals 3 here. Now we can put this back in. Now we can figure out the actual side lengths. We have 5 times 3 minus 2 in this case here is 5 times 3 minus 2 is, I believe, is 13, right? See here, 6 times 3 minus 5 is 18 minus 5 is 13 as well. So all these have side lengths of 13. Now over here we see x is 4x plus 1. We can substitute in. This is also 13 as well. So notice that everything here is 13. So the nice part about this is that these are regular polygons, these are regular pentagons here, and each of them have sides of length 13, each of them have 180-degree angles. Does that mean they're congruent or not? I mean, your intuition tells you, oh, absolutely, these should be congruent, absolutely should be congruent. But what does that really mean? Because at this point, if you look at our definition of congruence, it really isn't enough. There's not a lot going on in our definition here. All we have defined for congruence is congruence of angles and congruence of line segments here, because they all have to have same measures. These are polygons here. These are significantly larger. These are two-dimensional objects here. So that actually changes our definition significantly. So we have to sort of modify our definition here and see what happens, okay? So we're going to take a look at this here shortly. And we'll take a look at this idea in the next video.